I'm Timmy.
I'm Justin.
And I'm Nathan.
And this is Three Old Tech Dudes.
How about them taters?
Hey guys,
Hey, Nathan.
what's up?
Me. I'm still vertical.
Awesome.
It's the
Indeed.
most white guy statement a guy can make.
The
Still
price
vertical.
of gas.
The price of gas.
The price, yes, unfortunately.
Stupid.
So what did you guys do this week?
I'll tell you what. I worked a lot, but I drug this power supply out.
I've
I
seen
found
that.
it, and I found that at the Hamfest ages ago. I bet 10 years ago. I
Oh,
hooked
wow.
it to a CB radio once, and it made the most horrid noises.
How was that?
Just 60 hertz on the transmit and stuff.
Cool.
I was like, well, that's got bad
Aw.
filter capacitor. Well, you know what? That wasn't what was wrong with it. It was just a complete piece of garbage. Maybe one of the worst looking power supplies I've ever seen in my life. And
Poor little guy.
It was
He's
beautiful.
sitting right there.
He's-
Talk about him like that.
now he's already been surgically repaired, and basically mean, it's like if you cut someone's head off and put someone else's head on their body, it's that much change.
Oh, sure. I've done that before.
Yeah, so that's a common surgical procedure. So I
In
got
North
started
Korea.
on this, and I'm like, well, this isn't going so great. And then Nathan got involved, and with his magical voodoo electronics technician skills that he acquired years ago, rebuilt this thing from the ground up. And we think you'd enjoy seeing that, and so you're going to get to watch it now.
Whether you want to or not. Well, I guess I can always close the video.
Yeah. Don't do that, please.
What we have here is a Sears solid-state AC power supply. This little piece of marketing here threw me off a little bit. So I had to check the back and make sure that it is certainly a DC output power supply, just how they labeled it, I guess. It's pretty grubby, but is intact. I've had this for many years. I tried to use it one time, picked it up at a Hamfest. $5 works. Technically, it works. It's designed so that you can set a Citizens Band radio on top of it. It's got the little rubber feet, and they're actually pretty solid yet. Looks like it may have been able to be mounted, like hanging off a bracket maybe. That may or may not be original. Well, maybe it is. Somebody may have drilled it out. But this is pretty old, probably from the 1970s. Early 80s, I have no idea on this particular piece of equipment. It will not be high output as far as amperage. 1 amp, yep, so that will work for a few things. It'll work for your mobile Citizens Band radios for the most part. It will work for some ham stuff. I've run 2-meter mobiles on 5 amp power supplies, I think. It might work on a 1 amp if it's a 5 watt output, pretty low draw. It's not going to draw an amp usually. Something I do think is wrong with it is it, will have a ripple filter capacitors on its regulator. I think I hooked this to a Citizens Band radio once and it did not, it was just humming badly. So we're going to open this up and see what's in there. And we'll put it on the scope and see how pure its output is. Okay, got the top off. Didn't figure I'd bore you guys with that. Has 2 screws on top, 1 on the bottom if you flip, or 4 on the bottom if you flip it over. Just popped all those out, pulled the top off. To be honest, I've not been in too many 13.8 volts power supplies yet. That's a big ripple filter capacitor. My goodness. What are you anyway? 4,000 microfarad, 25 volt. That's something. So it's got a circuit breaker here on the bottom of this board. You can see the push button for it going through the metal there. Some other odds and ends. So I'll see if I can figure this out. I enjoy digging into old things like this. I'm not, hobby electronics is fun and learning about how all these circuits were put together. I mean, we got, I'm not sure what this transformer's deal is here, for example. Figure that out. See See if we can't come up with what this guy is, but let's see if it's how pure its output is on the scope. Okay, we have this powered up. I think we'll put it at 10 volts per division, direct current. See if we can get the position right. That's on center for me. I'm not sure how it looks in the cam. And tell you what, I'll go on the back of these screws here. There's your negative. Kind of see what I've done there back here. This will be on. It should jump one division and then a little above for 13.8. Okay, that's a good sign. Get you guys in here closer. You can see that it's slightly above that, so it's around 12, 13 volts, with volts per centimeter division being at 10. That's the DC output. I hope to see no or little AC output. That's good. That's interesting. I thought for sure there was bad hum on this previously, but maybe there's not. Let's put it down a little more. And now we're getting a little warbly. I think I might have to compare this to a different power supply. I see that, you know, okay. I don't think that ought to be like that. You set it to half a volt per division, you get a little ripple there, but we'll pull another power supply out here and see how it looks that we know is good. Okay, I've got my hands on this big pyramid power supply. It's higher quality and, you know, probably better built than this little guy. So we'll detach from this and see what it looks like up here. Okay, again, we're testing how much AC is on. Okay, look, there's a lot of AC just on this right off the bat. It could even be the filter caps in this. I don't know, so I'm curious. Okay, it doesn't seem as noisy at that setting. I've set to AC half a volt. I'll put it back to 10 and DC. It's kind of unstable, isn't it? A little hump in this one. Okay, what's that all about though? Because now it's just all over the map on its own. Oh, okay. I have this power supply too close to this because I flip off the power supply and the oscilloscope goes haywire. Yeah, there we go. Let's get this way out there. About quite a bit more distance. They're on the same power strip, so they may not help the eye. You get this thing close to the scope and it kind of is like, yeah. Magnetic forces, I'm sure, in this are affecting the plates and the scope tube. So, okay, let's try that again. There we go. I was going to say, this thing works great, this power supply. Yeah, you can see that that looks more pure. And there, yeah, we have no AC on it, which is what we want. There's no AC on the pins at all, so that's better. Let's go back to the Sears unit. Okay, yeah, look, see how noisy that is? And that comes right through the audio on an old Citizens Band radio or whatnot. It's sawtooth. Looks like a sawtooth wave. Okay. So that tells me that this big capacitor is probably no good. Kind of floored how big that is. Not really sure I understand yet how the rectification works in this power supply. I might have to dig in a little more, folks. Before I dig into figuring out the regulator, I wanted to verify, you know, that we didn't have a situation just like with the big power supply with this one, so I made sure to get them, you know, about as far apart as I can, and it does not, affect things a whole lot here. We got here a couple of diodes, maybe. Yeah, that's the rectification right there. Kind of funny looking diodes. However, that's all working. We're not worried about that. It's our filter that's the issue. So I just wanted to make sure it was normal. No user serviceable parts inside. Ha ha ha. So funny. Sure there are. Legalese to keep companies out of trouble. Okay. I've cut. Or not cut, but I did cut. I removed this cap. So I don't think it's working. I also measured almost 16 volts here, and I think that's way too high. I know it's not loaded, but my goodness. I'm not really figuring out how the regulation works on this, or even if it is regulated. It may just be stepped down to 15 off of here, because that's about what's coming right out of the transformer. So that's a little high for my liking. I may rebuild this into some sort of variable power supply, because it's of low value, really. I mean, these are pretty easy to come by, 1 amp power supplies for Citizens Band, and I have 3 or 4 different ones. We may have some fun with this one, but first, we're going to try something, just because I'm curious. Because that may be why this has such a big ripple filter. Is it's basically just, goes through the diodes to make it DC. I have this big box of 2200 microfarad capacitors. Big box of them. These actually came from the N9CMM house. You can see that video up in the corner. And these are new old stock, but they're electrolytics. And generally, I don't even know why I took them. I mean, I normally wouldn't. You wouldn't use these seriously just due to their age. Why? Well, considering this is probably actually the actual box. If you can read upside down, that says January 27th, 1970. These caps are older than the cap I pulled out of this. I'm almost for sure of that. So, but they seem to measure pretty well on the cap checker. So there's enough microfarads there to stop our ripple. So let's see what we can do here. Actually, we could probably parallel these. And what is it, 4,000 microfarad? These are 2200s, 16 volts. Running awful close to 16, obviously. Well, we'll try it, At most, we could have some firecrackers go off, but we'll just try that for fun. This will not be a permanent fix for those worried about that. It's not like I'm going to throw this into operation. I think this is going to become a project power supply. And why not start with a little experimenting now with some destined for the trash caps. Okay, I've just plugged this PS in. I've stubbed in just one of the 2200 microfarad 16 volt caps that are, only 52 years old. Make sure I'm not getting warm or anything. No, because we're running right up toward the 16 volt edge there, so making sure it's just kind of sitting stubbed in there, not touching the chassis of the unit. Oh, I need something to sit under that. It's making me nervous. There we go. Put it on my stripping tool. I've had that little multi-tool since I was about 10 years old. That particular one, that's kind of interesting. It's held up better than a lot of the cheap ones you get now. I don't think it was a real expensive one in its day. Alright, I think I'm going to check voltage real fast. This thing was running 1585 or something like that. Okay, see if we can get this checked here. So running 1585 at the pins. Man, that is high. I wouldn't run this on a radio without a voltage regulator in it. So I don't think there is one. It's just right off that transformer. Everywhere I check it. So it's like a 16-volt transformer with a ripple filter and a circuit breaker. Well, all right. And maybe a lot of these are built. I don't know. I've never really been in a 13.8 volt power supply like this. Some of you old boys have figured that out already, haven't you? Okay, I decided to flip this over to AC, 200 volts AC. This was showing like 35 volts on the output with this. That wasn't quite what it was showing on the scope, but who knows? I may have had something set up funny, but or this cheapo multi-tester is wrong. 35 volts seemed like a lot. It's still showing 34, so I don't know. Maybe it's not a ripple thing. Anyway, I'm curious how this performs on the scope at this time. I mean, the cap checked okay. It's not shorted, so let's look. Got it set to 20 volts. We'll flip to DC. Showing about 15, I guess. Curious on AC. Shows nothing on AC at 20. See, it doesn't match the multimeter. And that's really no better. I wonder if it's just the nature of this type of circuit. I don't know, but it sure was noisy on the Citizens band. I would think that 2200 microfarad is plenty enough to knock a ripple down. You know what we should do? Let's take it out of circuit entirely and just connect it without that. What's the worst we do? Smoke something? I doubt it. One moment. We're going to leave the scope set up just like this. Half a volt, 5 millisecond update, AC. I want to see what we get. I'm going to pull this right out of line and just kind of put it together. Okay, so basically what I've done is I did not put that cap back in line. I left the negative side of it off and just hooked the positives together. I don't know, this may not be right. Let's just see how it looks on the scope. I don't know. And you really need to draw a schematic out of this before I tinker with it much more. It'll either do nothing or it will work. Oh yeah, look at that mess. Okay, so our ripple is extreme now. Probably a full ripple of the full voltage. So maybe that other cap isn't bad. Maybe this is just a crappy design. Get you guys in tighter. I'm sure you saw it. It's not a. Let's change our speed here. Well, you can see how we're at 10 volts and it's dipping the full AC bit now because it's true AC on these terminals at this point. On both AC and DC, see, because you don't have flat DC either. It's just let's put it ground. It's just going to be on AC, you know, dipping above positive negative up here. Your rectified voltage doesn't have the reason it dips down. See, you're going negative here basically because it's push pull with the AC. I don't know, it's the right way to describe it. On DC, you have that rectified so that you have both halves above, but it's dropping all the way to 0 volts. So it's 0 to what was that, 5, 10, 15, just like I'm set at 5 volts. So the ripple works, it's just not perfect because it's not it's not regulated in my opinion. I think it should be cleaner than this. So I'm not sure what this little transformer brings to the situation. I'll have to look up what kind of transformer it is and such because it's in the positive line past the rectification. But if you note the scope screen, it's the same output on both sides, so I don't know. So I'll tell you what I think I'm going to do. I think in a future episode I'm going to, or maybe in this episode, I'm going to get the parts to build a regulator board for this. We'll trim it out, that's how we'll start.
That's fine. So one thing we're going to do is we're going to rebuild this power supply using parts out of a couple of computer power supplies. 5. This one's silicon. The other one, I'm not sure what it was. But the other one's 0.1. And so that should be there. Yep. Okay. That's fine. We'll use this. I can do that because we have an insulator. And then find the parts we need. This will be our voltage regulator. This will be replacing those 2 diodes. We're going to do this in the worst way possible, which is floating it above. Everything's fine.
We pulled this board out entirely with the breaker on it that you saw earlier in the video. So we decided we don't like this. We're going to build a regulated power supply, basically.
Yeah.
Instead of what
Kind
the
of cheap
70s nightmare is that it...
Yeah. We'll correct it.
We also decided the giant filter cap is sufficient.
It's good. Yeah. We're going to add, wherever it went, one of these, one of those, and then this. To just in a couple spots. So we'll go with the schematic. Basically, the schematic. Initially, I'm not going to use the 2 diodes. We'll just let it sit there at 12 volts exactly. If you want to, we can put those in.
Add that later. Yeah.
Or you can replace this voltage regulator with a slightly higher voltage.
Sure. Yeah.
The question is this the right thread for this screw? Or is it at least close enough? That is actually the right thread. Yay! Now I need to get a feed through, plastic feed through, so we'll short the thing out to grow.
Right.
Which would be bad, because you don't want to short that stuff out to grow.
We don't.
Oh, there's one. Here's one. So this is why I keep lots of parts, because, well, that and just nuts, but, you know, because everyone needs to keep parts. But that, right there, pop it dude out somehow, is a proper feed through.
There you go.
So this will sit there. And then this is the insulator for the back of it. Here's this. We can see what it does. Sweet. Always handy. So we can then mount this like this.
Like where the board used to be.
Yeah. And we'll put the nut on the bottom of this. Tighten it down. Do you have a pair of pliers or needle pliers?
I think I do.
Okay, if you don't, in my box there is. And there. Oh, sweet. Okay. So hold that. Take it down. Now, if you're doing something like this, a few just safety pieces, of information. Take your meter that goes ground to that metal you just did, and it should be open or no beep.
No beep.
But there would be a beep.
No continuity.
There
on the, yep.
But not there.
Okay.
So that way you don't cause fire. Okay, so the simplest part of this is actually that, because we'll solder. I can get this to be around there. There we go. So we'll solder red lead, and then the output is in the center.
Yep. To our, yep.
Yep.
Well, that's easy. I guess we'll do that real quick.
Yep. So that is the rectifier for the circuit. So that is this.
Ooh, got it. Yep. Here's your rectifier. All right. Well, I guess I'll let you dig into that. You're better at me anyway.
That's very debatable.
It's just tricky. Tricky for all of us.
Clean those up a little bit. I don't really have a good place
That's
to
fine. Yeah.
throw solder. So
It comes off once it dries anyway. So
true, it does just pop off. Yes, I know. You're supposed to run it through sponge and blah, 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 blah. This is literally like a dirt cheap way to do this.
yeah, there's dirt cheap soldering iron for that matter. So.
Yeah. I'm going to go ahead and pre-tin these ends, or re-tin them, I guess. Okay. Blonde solder, that's good.
Right in the face.
And the smell is so fun. Yeah. Cut. So. There's one. Stinky. Okay. And of course, if we had the good board mounting good board mounting system in here, it would be better if we did actually
That's
on
true.
board with this and all that kind of stuff. But it's a 1 amp 12 volt power supply. Give me a break.
We're kind of just working with the tools we have on hand here. So.
It's cheap,
Yeah.
and I'm trying not to burn myself on this one, 'cause I've never done that before.
Never ever.
Mm-hmm. Thin solder. There we go. So when you're soldering, and yes, I know I'm doing it wrong. Just be okay with that, because I'm tired of hearing people go, "You did it wrong. That's the worst way to solder ever." Blah 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 blah. blah.
One video, somebody called me out with this soldering iron for not having a chisel blade on it. So.
I'm like,
It's like it has what was on it when I bought it at Radio Shack in 2002.
Yeah.
I think I've changed it once.
well, people.
It's YouTube. Do it your way. This is how we do it.
Yeah,
This is the 3OTD way. We do it the way we do it.
Here's the thing. Never do this the way I've done it.
Do it your
There
way.
you go. There
That's
you
right. Yeah. What is it? We watch a channel where the guy always puts time and data data. This is mostly for entertainment. That applies here.
Yes.
So.
This is digitals.
It is.
Derek didn't watch this channel. There's
Nope.
no way.
We just want to steal his
Plug me in.
phones.
No, it's from Derek. What's his last name?
Beery.
Beery or something?
Yes.
Yeah.
Ice
He
cream
actually
garage.
he hid it for a long time, then he put it on a car.
He did, yeah.
All right, so what I'm going to do is, I'm going to steal one of your leads here.
Sure.
Move the extra wire from the lead.
Right.
I'm just going to get this out of the way. Get this to the ground. Okay. Yeah, go ahead and put me in.
Oh, sure. Plugging in. It is live.
Should me read? Yeah. Because there's no filter on this right now, so
Right.
this is basically just pulsating DC.
You're right, 11.4.
Yeah, I'm going to plug it. So let me show you what you normally have. So I'll draw out. Actually, you know what? Let's show them what it looks like.
Sure.
All right. So go ahead and plug me in,
Okay.
and just make sure there's no smoke.
Plugging in.
It's fun.
There you go.
So this, which I'm going to move it down. Where's the adjustment?
Right there.
Okay. So actually, I'll look at this. So if you look at ground, boop, kick it up.
So you got to speed it up for my camera.
Yeah,
It's
so-
not catching it well.
So is it seeing it now?
A little faster. Perfect.
Okay.
Straight line. Yeah.
So it's going to look a little wrong. So if you look at this
Mm-hmm.
in AC, it's not going to give you the right answer. But in DC mode,
There we
you
go.
actually get
Yeah.
center to this. But what you actually see is pulsating DC, and the capacitor smooths that out. Is what it actually does. So we'll put a capacitor in here, and I'll show you what it does real quick. So we're going to plug it. This side, do this hot, bam, and we use this. That. The green, the other one. Oh, there it is.
Yep.
Okay.
I got a bunch more if you need them.
For this, no, because I'm just literally going to
Put
demonstrate.
it in the circuit. Okay, here's your cat
So-
back here.
Is it negative here, positive here?
Yep, that's right. Yeah, the black pole on the side of it says it's negative on the cap.
Oh, does it? Okay.
Yeah. Because I played with it quite a bit earlier.
Okay, so we'll go ground.
Green. That makes sense.
Yeah, so it's at least closer. Okay, so let me So I got this really tight here.
It pulls straight off if you just
Oh,
want
it does?
to.
Yeah, it does not
Yeah.
screw. Oh, okay. So we'll look back at this again. Now remember what we had before, and now you should see flat line.
Yeah, went straight up there.
Yeah. So ground to flat.
Yeah, and we
You see
couldn't.
that?
You couldn't get anything but a sawtooth mess out of it before.
Yeah. Can you
On the
see?
old circuit. Yep, looks good.
All right. So that's what a capacitor does. It smooths out from pulsating DC to flat DC. So let me go see what I find. Let me unplug this. And we'll plug one of these small ones in. That's much less effective, but is still going to kind of show you. Then you'll start seeing this mostly DC with a little bit of hump on the top of it.
Right.
Kind of look. The thing is unloaded. It's kind of hard to get that
Sure.
exactly right, but you know. I saw 0.1 in this. 104. There you go. So 104 is 0.1. And these are non-porous. It doesn't really matter.
Right. No matter which way it goes.
Yeah, in this case. Okay, so now we're hooked back up. Are you still recording?
Yep, not powered though. Ready?
Yep.
There you go.
Now, see that? This is not able to completely filter out that ripple, is what it's called.
Turn up the time base a bit, the sweep time. There you go. It shows better that way.
Okay.
You can see the dip in it though just fine. Yeah.
Okay, so that dip in there is because it really can't completely filter that out. Because keep in mind, this is only at 60 cycles for the US power grid. If this is Europe, it'd be 50, but it's the same exact issue. So electrolytics are better at filtering that drop part out. They kind of basically take up in between hump cycles. So between your, if you have pulsating DC like this, right, as what happens is that these small capacitors, you know, as this rises up, they're kind of okay, and then, you know, like this. They filter out most of this drop, whereas the other ones just give you a good flat line. I know it's not a great drawing, I'm sorry. I never said I was an artist.
Covers the bases.
Yeah, so that's what a capacitor actually in a power supply circuit is doing. It's either filtering out noise, which is the same idea, or it's filtering out the ripple from the AC line itself, from the actual pulsating DC to make it flatline DC. So if we put in positive and ground, so this is a 1000 mic 35 volt capacitor. I have no idea what the DC is at. It shouldn't be anywhere near that thing.
No, it's not.
So we do this. You notice it's able to actually completely
As
filter
flat
out.
as can be, yeah. Absolutely.
So we get 5 volts per division.
Yeah, that's where you're at still. Yeah.
5, 10. It's about 14. So that's not bad.
Right.
Yeah. So that's what the capacitors do. You don't have to have big caps. The small ones allow you to see what that ripple kind of looks like. And so what we'll do is we'll take this and then run this through a regulator, which then brings that voltage down. Also filters it a little bit itself. A ton, a little bit. And we'll use the small filter cap to really take out noise. And this one across the main line out here to just kind of help with power sag because of like so you can connect something up. And the big one actually will do the pre-filtering at this point right here. So the regulator, this one and this one will be after the regulator.
Okay.
So they're going to be there for noise. And we use this noise filter, which is just a coil, to just take out high frequency. So this actually should be pretty decent when we get done with it. So
Sweet.
turn that off.
All right.
And you'll notice, actually, that capacitor is still holding the
Sure
voltage
is,
up.
yeah.
And it will. And it should hold it for really quite a while.
Right, and it'll eventually float down. But
Now-
without a load, it's going to sit for a while.
Yeah, without load, it'll sit for quite a while.
They function like a battery that doesn't hold charge very long is
Yeah.
somewhat of a way to describe one.
So if you used to have parents or whatever, who said, don't ever touch even if picture tubes been turned off in an old television set for years, it's a capacitor.
I was told
right?
that when I was a kid once. Yeah.
Just like this, it actually does store voltage. Now the reality is, years ago they came up with a bleeder circuit, which is just a resistor across this, which brings it down. But yeah, that was the same exact thing. If this was high enough voltage, touching this would be really bad. It's not. It's 15 volts. So
Sure.
So, some people are like, oh, you touched voltage. It's DC. Okay. And it's not high. It's
Right.
low. So when we get done with this, it will be 12 volts, just give or take like 0.1.
Yeah, it bothered me that it was 15.8 on the terminals. I'm like, that could burn something up and hook a
Yeah,
radio
that
to
actually
it.
is not good for any kind
So
of radio.
I don't. Surely, if it was that way from the start, who knows? But it wasn't
Yeah.
good.
So we'll figure out a way to mount the regulator, and then we'll come back and show it to you. Okay, so this is really cheap and dirty.
Oh, it's crazy, but look at that. What we got going on here, Nathan?
So
Let's get
put-
zoomed in on it real close here.
So we've got the double diode array, the exact same system that was this, and just in one chip, because part off an old computer power supply, and then we wired up basically this circuit. So I've got this capacitor is that one, and except the diodes, ignore that. We just grounded this because. Now, we should fuse the main lines off this. See this over here, you can see a little bit better. So we've got the 1000 mic capacitor across the outputs here. This coil is here. This 0.1 is here, which again, it's very like cheap, dirty, make work. This is the voltage regulator, which is 7812. This cap is here. Like I said, these two diodes are actually that. Main transformer. And then plug. Right. So let me get.
This is really a project on the fly. We weren't even planning on doing it, and so it's built out of the components on hand. And we didn't have any project boards or anything with standoffs we could mount on. So
yeah, it's
mounted to the chassis and the components in this case.
It's very not. Don't do it this way. Just laugh at us and go, oh yeah, you crazy weird idiots. Okay. So, can you see these?
Yep, got everything on screen.
You should be able to plug this in and not have smoke. Hopefully. Yeah, let's see if I wired it up.
Would be a good outtake.
Yeah. If everything is.
I always double check too. That's exactly what I do before I plug it in.
Yeah.
And it's in, and it looks right.
1.7. Let's make sure. I just want to tap it.
I'll make sure it's not too hot. Yeah.
Nothing burned up. Nothing got fried. Nothing caught fire.
Starting to drain off the cap a little. It's starting to drop too.
Yeah.
See the line coming down on the screen too.
Okay, that's not hot. So. 11 point. It's a little low.
11.7-ish, yeah.
Should be a little higher than that.
Yeah.
Let's see if I can burn myself.
A regulator would get the hottest probably. However, I don't think it's bleeding off a whole lot of voltage. So,
That's cold.
yeah. This is what, 25? We
We're
checked the
probably
transformer
losing-
around 25 volts.
I bet we're losing a bunch. Let me pull this
in the
off.
coil there.
I bet that coil's just eating it in, ground out.
Well, maybe not.
No, that's just. It's a little weak, actually. That's okay. 11.7. It's a touch low. 17 to 17.
Yep.
So down 17.02. Yeah. We're getting. Well, we're not floating anything. It's a little low. It's cold though.
Yeah.
It's not hot.
So
yeah,
let's check it on AC and see how clean it is. Look at,
Well-
that's obviously very clean, but
Yeah, this is the 12 volts. Yeah, so it's
so would you have any AC bleeding through? Shouldn't with those caps.
no, you'd see it there.
Oh yeah, you would, wouldn't you?
Yeah, you'd absolutely see it there. So it is. Look, put this back in here and tighten her down. There we go. So this is the voltage, and the other thing is I can't guarantee this is exactly right because it's a hobo freight meter. So
like a little tilty screen there.
Yeah, that's.
I actually like the tilted screen. I've never seen this have like the wrong voltage listed though. So
Right.
So we can set. I'll set this a little bit better. And what am I at? 1, 2, 2. Okay. So let's set it. So 2, 4, 6, 8. 2, 4, 6, 8, 10. Oh, there we go. So unset these. Two, 4, 6, 8, 10. Well, I say that's about right. Actually, that's
pretty close on the scope.
it's actually. I'd say it's actually a little better than this. I think it's meters law. Where's your other meter?
It's over here.
It's metered. And we have that one I've got that's that little handheld oscilloscope. It actually reads all of it on screen. It's pretty sweet, actually. Let's see what this one says.
I could have brought a fluke if you guys would have said.
Well, they're I don't have a fluke. I'm cheap.
Well, I didn't buy a fluke. It was my father's.
7.6. No, that's reading the same.
Showing the same.
Showing the same. And it would be better if we had a variable regulator. We could adjust it up, but we need obviously an actual circuit board and that thing to do that because there's other components to it. But anyway, there's a basic little 12-volt power supply.
Yep.
That's actually regulated now, properly filtered.
Yeah, just run a little low on the output. Not sure why.
Yeah, but
it'll work.
it's definitely this thing doing it, and you can tell it's that and not overload because
It's
cold.
17 coming in anyway, right?
Yeah, it's 17 coming in, but it's just cold. So, if you're going to do this, you really should do this properly. You should do the actual circuit board in there.
It's
and
literally a 30-minute.
Yeah.
Nathan has all the parts in his various component stash. Let's see what we can make.
Yeah, but this is the schematic here without the diodes, so ignore the diode part of this. I'll take those out, actually.
There you go.
That's it. Without, of course, we bypassed that too.
Yeah.
But, I mean, it works.
So we may improve on this in the future, but it's a fun experiment and just a power supply I had lying around that I knew was kind of junky. So
Yep.
now it's junky in a new way, but also better.
True. If you needed something at basically exactly 12 volts.
Also, it was showing 15 volts on the output, which of course unloaded, but that was awfully high in the old circuit. So,
Yeah.
I'd almost rather be a little low on a Citizens Band radio versus high.
Well, yeah. And the other thing you also think of is that this is not regulated keeping output, so it's supposed to adjust constantly.
Yeah.
And it could just be the fact that this has just got enough age on it. And this chip actually came out of a computer power supply.
So it's a salvage part, yeah.
It's salvage part.
Yeah, that's cool.
Well, actually, the capacitors weren't. They were new. But that and the diode array was actually salvage part.
There you go.
So is some of the wiring that we just,
Yeah.
I just had,
Absolutely.
So
All right. Well done, sir.
it works. I wish it was more dead on 12 volts, but it's about a little over a quarter volt. It's a little out of spec, but
Yeah.
it's probably a very old regulator.
Yeah, it is.
I could probably find another one we could try in there or something.
We'll have to look at that eventually. All right.
There you go.
That'll work.
Oh man, that was quite an adventure we had, Nathan, wasn't it?
Yeah.
All your vast library, parts hoard, component pile really came to the rescue that time.
Yeah, I mean, all that.
Yeah.
The whole, I should order this. What do you mean order?
Don't
Order?
order. Ask me.
Don't
first.
order parts.
from me.
Nathan has parts. Nathan has been collecting parts for
Parts binning. That's the
way
term
too
I was
long.
looking for. You are a parts binner. You bin parts. You have your own parts inventory. So
Sure, we'll go with that.
it's just not inventory.
Everyone else calls it just a giant pile of junk
What
and
do they
stuff,
know?
but sure, it's
What
parts
do they
binning.
know?
You know
Sorry,
that
Sarah.
little cabinet thing they had in the middle of Radio Shack's That has nothing on him.
No, I agree. He has
Well,
more than that.
A lot of it, a lot of things came from that actually. Whole lot of stuff. Because I've never been to Radio Shack before.
You shouldn't lie to the people like that.
I used to live there. Hey.
Well, let's see who's living in the comments, Asylum.
Alrighty.
All right, it's time for welcome. No, that's a different segment
It's
altogether.
not, yeah.
It's time for Echoes from the Asylum, that part of Three Old Tech Dudes, where we get to hear from you, the people watching and commenting on our misadventures in electronics and old tech and new tech and fire and rain and hail and crickets and locusts. Anyway.
Goodness.
Okay.
Covered so much.
I was on the wrong tab. That's why I was lost there. I couldn't figure out where I was at.
That will happen.
Oh, geez, I copied one that had a read more. Are you kidding me?
Oh.
And that's a good comment. Well, we're going to go find that for reals. Hang on a minute. Hang on.
Hold, Liz.
One moment.
Timmy
We
in
don't have to
post.
hold long. Here it is. All
cool.
right. This is on the Vintage Digital Cameras video.
Oh, yeah, yeah.
Oh, okay.
Actually, one of the last videos we shot here. We've not shot here in quite a while. Film,
haven't,
video,
have
digital clips. Bill B writes, 12 minutes and 30 seconds. Timmy and Nathan mentioned the camera is memory stick compatible. This would be referring to one of the Sony cameras.
Yeah,
Yeah.
because it's like a weird.
I think we're getting to that here. When I originally heard that, I went to look for the floppy disk adapter I'd gotten years ago as part of an eBay purchase. I couldn't find it and thought I must have thrown it out. But 2022 brings decluttering to my home, and I found it. I saw that Sony's support site still has the manual and drivers for Windows 2000 XP. It is its model number is MSAC-FD2M. I'd be happy to send it to you. Let me know.
Way cool.
What say you, Sony camera owner?
Well, we have a P.O. box. If you want to send us something, we do have a P.O. box.
We'll splash that up here.
Yep.
So just
So-
mail it there below, and
Yeah.
I'll reply to your comment, Bill, and let you know. So we'll play with that, see if we can get it working. So
Funny enough, like a couple of weeks after we shot that, I found like that exact same camera
Yeah.
at a Goodwill and bought it. So now I have one too.
I do remember that it did say memory stick compatible, and then kind of in smaller print it said with the available floppy adapter. So that's
Yeah,
kind
it's
of,
like weird adapter. Yeah.
So it's kind of interesting. So.
It's it sort of is, sort
Right.
of, but it is what it is. So, yeah.
Awesome.
Dude, welcome to the waves.
That part of each Three Old Tech Dudes episode where we welcome a new ham radio operator to the hobby of amateur radio. This episode, we welcome Marcello Guerrera of Brownsville, Texas, KI5UIW, to the hobby of ham radio. Marcello has tested straight to general as his first license. Congratulations and enjoy the hobby. Thanks for watching this week, guys. You can find us on social media at facebook.com/3oldtechdudes, Twitter at 3oldtechdudes1, and on Rumble, just search for 3 Old Tech Dudes. There may be a URL. I don't remember. We also have sort of
just
a
got it.
website, which may or may not be done by the time this video is out, at 3oldtechdudes.com.
Yep. Which it's there, but it's not.
there. We've got a better
We're
one
redoing
coming.
it. Yeah.
And you can email us at thedudes@3oldtechdudes.com.
Yep. Also, when we get the website done, we'll have merch on there. So
We keep promising merch. We won't let you down, but it's coming.
we have it. In fact, if someone really wants it now, you can send us a message through Facebook, and I can
We got some
send you
t-shirts.
the link
We
to
got
it.
some contact. So
Yeah, we have a guy. It's a local guy making them, and he made this one. He's made a few other ones we've had, and yeah, I can send you the link to it if you need it.
Absolutely.
If you really want it right now, which is fine, or you can just wait till we get the site done because that's on my to do list.
yeah. Well,
So yeah.
anyway, guys, thanks for watching.
Yep.
And we'll see you next week with something else to look over from the old tech world. I already know what it is.
I bet I do too.
That's right. Hey, till next time, I'm Timmy,
I'm Justin.
I'm Nathan.
and this is 3 Old Tech Dudes.
Later.
Thanks for hanging out with us here on 3 Old Tech Dudes. Please subscribe to us here on YouTube for more tech old and new, tinkering at the workbench, repairs, ham radio, electronics, computers, and more. Please like this video and share 3OTD with your friends to help us grow the channel. We tweet at 3 Old Tech Dudes 1 on Twitter, and you can keep up with us on Facebook. Just search for 3OTD and look for our logo. Thanks so much for watching.